Hello, I welcome you all to this channel again. So last week or some 3-4 days back, for all inorganic questions, I had provided solutions in two parts from this KSET paper 2021. Whatever inorganic questions had come, ಅದಕ್ಕೆ in detail answers ಕೊಟ್ಟಿದ್ದೆ solutions. Authentically ಎಲ್ಲದನ್ನು verify ಮಾಡ್ಕೊಂಡು answer ಕೊಟ್ಟಿದ್ದೆ. And like many of you had requested for physical chemistry detailed solutions, as it was not available in as per my knowledge is concerned, YouTube ಅಲ್ಲಿ detailed discussion on physical question KSET-21 paper ಮೇಲೆ ಎಲ್ಲಿಯೂ ಆಗಿಲ್ಲ. So therefore many of you had requested that. So now I am doing that, and this will be the first part of the video where I'll be taking 18 questions. Totally 36 questions were there. Say 65 to 100, 18 plus 18, totally 36 questions were there. And first half of that, like first 18 questions I'll be taking here. So the first question, it was simple enough. It was based on the knowledge of vibrational activity and say rotational activity, that is IR and microwave activity for the molecule BAB, and they say that this molecule, it is non-linear structure. So non-linear anta helindre it should be bent kind of structure, angular structure for the molecule BAB, just like water molecule. So if you can imagine that water molecule ige enagutte ade idukku agutte anta ankonಡ್ರೆ definitely it will be correct, right? So it's just like water molecule. And for this molecule, definitely dipole moment 0 irodilla. There will be net dipole moment for this molecule. And the necessary condition for microwave activity, it is presence of permanent dipole moment. Permanent dipole moment non-zero ide anta helindre microwave active. The molecule, it should be microwave active. So next one, during vibration, definitely different vibrations are possible for this molecule, and during those vibrations there will be change in dipole moment. That is the necessary condition for vibrational activity, or say IR activity. I should call it as IR activity. So any molecule which shows change in the dipole moment value during the vibration, that will be IR active. So therefore this particular molecule is both microwave active as well as IR active, and the molecule, it should absorb in both the regions. So that's how A, it is the correct answer for this. So even we can look at the other options and why they are wrong. Always that also has got equal importance. This molecule will show mutual exclusion principle. No, mutual exclusion ಆಗಬೇಕು ಅಂದ್ರೆ it should be linear ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಆಗ್ತದೆ, but they say that it is non-linear. Inversion centric ಇರೋದಿಲ್ಲ, so therefore mutual exclusion principle follow ಆಗೋದಿಲ್ಲ. This molecule, it has horizontal plane of symmetry, right? So water molecule ಅಂತ ನೀವು imagine ಮಾಡಿದ್ರೆ, so both the planes, two planes are possible, but both those planes, they will be actually vertical planes, technically speaking. Horizontal plane irodilla idralli, so therefore this statement, it is also wrong. So last one, this molecule had it has zero dipole moment. No, you can expect net dipole moment for this molecule. So B, C, D all are wrong. You are just left with A. That is the correct answer. This is very simple question. Two questions have come from statistical treatment of analytical data. So now they are asking the central tendency of the data. It is not expressed in terms of, so like midpoint, or say ಕೊಟ್ಟಿರೋ ಡೇಟಾ ಸೆಟ್ಟಿಗೆ midpoint ಯಾವುದು ಅದಕ್ಕೆ ನೋಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ mean, it speaks about that itself. Mean, it is nothing but average. So it speaks about the central tendency of the data. Similarly, mode as well as median, it is exactly midpoint. So mode, it is the range in which the value it is spread. That one you can consider it to be mode. So all these, they talk about the central tendency, whereas this standard deviation, it is different. Standard deviation, it indicates the dispersion across mean. So mean value ದಿಂದ ಎಷ್ಟು ವೇರಿಯೇಷನ್ ಹೋಗಿದೆ, different values, how they are, say if this is the midpoint, let's say that midpoint or mean value, it is here. So ಇದರಿಂದ ಹೀಗೆ ಅದು ಎಷ್ಟು deviation ಆಗಿದೆ, so that one, it is usually indicated by standard deviation. So therefore standard deviation, it is the answer. This will not express the central tendency. So the next question, again, it is from statistical treatment itself. So they have asked about the least square fitting of a data of the equation y is equal to mx type straight line equation, right? But C illa, intercept 0. The coefficient m, slope m, how it can be estimated and kelidare. So usually we get this formula. By making use of this formula, it is possible to calculate m, but ಈ formula illa. Therefore separately adannu ಹೇಗೆ ಮಾಡಬಹುದು, that can be seen. Y is equal to mx, that is the equation. So if I apply summation, so summation of y, this will turn up to be summation of y. So m, it is constant, so therefore ಅದಕ್ಕೆ summation apply ಮಾಡೋದು ಬೇಕಾಗೋದಿಲ್ಲ. m into summation of x. So then if I multiply this with the summation of y again, this will become summation of xy. and this side it will become summation of x square, right? So sorry, summation of x is to be multiplied. So in that case I can get the equation in this format. So now m that will be is equal to summation of xy, if I simplify, divided by summation of x square. So that you can find here in option B. So that's how option B is definitely correct answer for this. So next question, it is regarding dichlorobenzene molecule C6H4Cl2. So it will have point group symbols on ಕೇಳಿದ್ದಾರೆ. So which means a little good question itself. So you should know what all variations are possible, which all different types of dichlorobenzenes they are possible, that you should know, right? So dichloro ಅಂತ ಹೇಳಿದ್ರೆ it can be ortho substituted, it can be meta substituted, it can be para substituted. For all those, what are the point groups that they have asked, right? See, again, good knowledge of symmetry and uh, point groups, it is necessary, and in my channel you can find very good videos which had made use of um, 3D animations to explain up to this fact, up to point groups. You can just watch those videos if you want to understand these facts in more detail. Directly, if I come to question, so the para isomer, if you take, so para isomer, it will be having one principal axis that can be considered to be perpendicular to the plane of the benzene molecule, and two more vertical, two more subsidiary axes will be present. This will also be axis of rotation. This will also be axis of rotation. Therefore, C2 plus 2 perpendicular C2s, that will be D point group, and then definitely this molecule, it has sigma H. So if sigma H is present, that point group, it should be D2H. Of course, you should know the method of determination of point group, so then only you can do this, is D2H. Whereas these two, if you consider, both of them, they have C2. In this case, orthoisomer, here is the C2. In case of meta isomer, here is the C2. And along with that, you will find two vertical planes, right? So though benzene molecule ಯಾವ plane ಅಲ್ಲಿ ಇದೆ, ಆ plane ಇದಕ್ಕೆ ಇದ್ರೂನು, that is not actually by definition sigma h ಆಗೋದಿಲ್ಲ ಅದು, it is not horizontal plane. So two planes whatever are there, in both the cases they will be vertical planes. So therefore, like if you have C2 axis and two vertical planes, if you know that it is C2V point group. So point groups that are possible for C6H4Cl2, it will be D2H and C2V. Therefore answer, it is C2V and D2H, that is option A, right? But so you should know, like for which isomer it will be D2H and for which isomers it will be C2V. That point you should know. So it has been given here, ortho and meta, that will be C2V, and para isomer, it will be D2H. Okay, the next question, it is also on the basis of symmetry and group theory itself, or like symmetry and point group identification itself. So they have asked the symmetry point group symbols for tripod and beaker. So many times I have said in my previous videos also that this 2021 paper, it is based on 20 reference. So 20 also, in KSET-20 also there was a question based on the identification of point groups of some alphabets. So this time they have given tripod and beaker, because we all are chemistry students, so therefore tripod and beaker they have asked. So tripod, it is not at all necessary, because if you look at the options, in all the options for tripod they have ascribed the point group C3V, and it is correct. For tripod you will be having C3 axis here and three vertical planes, as I have indicated, it will be there. So therefore it is C3V. But here it is little, not difficult, but little confusing, because beaker, what it has is, it does not carry any rotational operation. So like rotational axis irodilla. What you can have is, considering its beak, you can just consider one plane, right? So that plane we can just call it a sigma. So whether this is vertical plane or horizontal plane, that identification it is difficult. Yakandre that identification it depends. Bere proper axis of rotation yavudu ide, adar base mele idu vertical plane ಅಥವಾ horizontal plane ಅನ್ನೋದನ್ನ decide ಮಾಡ್ತೇವೆ. Therefore ಅದನ್ನ just sigma ಅಂತ consider ಮಾಡ್ತೇವೆ, and the corresponding point group, like where only sigma is present, that is actually CS point group, right? So but like rarely this CS point group, it will be ಯೂಶುವಲಿ ಎಲ್ಲ ಬುಕ್ಸ್ ದಲ್ಲಿ CS ಅಂತಾನೆ ಕರೆದಿರ್ತೇವೆ, ಬಟ್ ಇವನ್ C1H ಅಂತಾನು ಕರೀತಾರೆ. C1H ಅಂತ ಹೇಳಿದ್ರೆ just to indicate that it has one plane and C1 axis. So this CS point group, it will be even called as C1H. So like if you have made sure that ಇಲ್ಲಿ ಈ ಉಳಿದಿದ್ದು ಯಾವುದು ಇಲ್ಲ ಅನ್ನೋದನ್ನ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೊಂಡ್ರೆ, then you are left with only option D. So in that way also you can conclude that option D is the answer. So if you just look at the other options, so here they say it is C infinity V. In that case, you can expect C infinity axis here, but C infinity axis irodilla. So on that axis, by any angle if you rotate, you should get equivalent orientation, that is C infinity axis. Adu illa. So therefore this cannot be C infinity V. So C infinity V chance ಹೋಯ್ತು. Then C2V ಆಗಬೇಕು ಅಂದ್ರೆ you should have C2 axis, that is also not there. Here also C2H, it requires C2 axis, presence of C2 axis. So ಇಲ್ಲ ಬೀಕರ್ದಲ್ಲಿ ಇರೋದಿಲ್ಲ. So therefore you can just go with, even if you do not know that CS, even it is called as C1A, you can mark that option D. That is the correct answer for this 69th question, right? 70th question, it is good question, definitely, no doubt it is good question, but difficulty level of this particular question, it is almost equal to the CSIR net 4 marks question, right? So little odd ಅನಿಸ್ತಾ ಯಾಕಂದ್ರೆ ಕೆಲವೊಂದು ಕ್ವಶನ್ಸ್ ಅನ್ನ ಬಹಳ ಸಿಂಪಲ್ ಸ್ಟ್ರೇಟ್ ಅವೇ ಕೇಳ್ಕೊಂಡು ಕೆಲವೊಂದು ಕ್ವಶನ್ ಅನ್ನ ಫಾರ್ ಸೇಮ್ 2 marks ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಎಂಡ್ ದಲ್ಲಿ ಕೇಳಿದ್ರೆ ಇಟ್ ಇಸ್ ಕೈಂಡ್ ಆಫ್ ಇಂಬ್ಯಾಲೆನ್ಸ್. ಬಟ್ ಸ್ಟಿಲ್ I don't know how many of you have done this. Like ಇದಕ್ಕೆ ನಿಮಗೆ ಟೋಟಲ್ ಐಡಿಯಾ ಆನ್ ಸಿಮಿಟ್ರಿ ಅಂಡ್ ಗ್ರೂಪ್ ಥಿಯರಿ ಇರಬೇಕಾಗ್ತದೆ, ಅದರ್ವೈಸ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್ ಟು ಡೂ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್ ದಟ್ ಈಸಿಲಿ. ಇವನ್ ಇಫ್ ಯು ನೋ ಇದನ್ನ ಮಾಡೋದು ಹೇಗೆ ಅಂತ ಗೊತ್ತಿದ್ರೂ ಇಟ್ ಟೇಕ್ಸ್ ಟೈಮ್. ಸೊ ಮಿನಿಮಮ್ ಒಂದು 5 minutes ಬೇಕೇ ಬೇಕು ಈ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ. ಸೊ ಈ ತರದ ಕ್ವಶನ್ಸ್ ಇದ್ದಾಗ ಮೈ ಸಜೆಷನ್, ಲೈಕ್ ವೈಲ್ ಅಟೆಂಪ್ಟಿಂಗ್ ದ ಕ್ವಿಸ್ ಆರ್ ವೈಲ್ ಅಟೆಂಪ್ಟಿಂಗ್ ದ ಟೆಸ್ಟ್, ವಾಟ್ ಯು ಶುಡ್ ಡೂ ಇಸ್ ಯು ಶುಡ್ ಜಸ್ಟ್ ಲೀವ್ ದಟ್ ಕ್ವಶನ್ ಫಾರ್ ದಟ್ ಮೊಮೆಂಟ್. ಯಾವ್ದು ಅದು ಸಿಂಪಲ್ ಆಗಿ ಆಗೋದಿಲ್ಲ ಅಂತ ಕನ್ಫರ್ಮ್ ಆದರೆ ಲೇಟರ್ ನಿಮಗೆ ಟೈಮ್ ಇದ್ರೆ ಅದನ್ನು ಅಟೆಂಪ್ಟ್ ಮಾಡಬೇಕು. So how you can do this, I'll just briefly tell this, right? So regarding this also, IR activity and Raman activity, regarding this also there is one video in my YouTube channel, you can just watch that, right? So illi iga concerned with this question, this is the molecule that they have given. The molecule, it is they have just mentioned that it is butadiene, but the C2V point group ಆಗಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ it should be 1,3 butadiene and it should be cis. I think they have mentioned cis ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. It is cis 1,3 butadiene. This is the molecule which can go to C2V point group, right? So now first what we should calculate is, ಅವ್ರು ಕೇಳ್ತಾ ಇರೋದು, they are asking about IR active modes. ಟೋ ವಿಬ್ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಸೊ ದಟ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್. ಬಟ್ ಅದರಲ್ಲಿ ಇನ್ನೊಂದು ಟ್ವಿಸ್ಟ್ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ದೇ ಹ್ಯಾವ್ ಸೆಟ್ ದಟ್ A2 ಇಟ್ ವಿಲ್ ಬಿ IR ಇನ್ಆಕ್ಟಿವ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಎಸ್, ನಿಮ್ಗೆ ಇದು ಕ್ಯಾರೆಕ್ಟರ್ ಟೇಬಲ್ ರೀಡ್ ಮಾಡೋದು ಗೊತ್ತಿದ್ದಿದ್ರೆ, ಸೊ ಇಫ್ XYZ ಇಲ್ಲಿ ಎದುರಿಗೆ XYZ ಇಲ್ಲ ಈ ಥರ್ಡ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ IR inactive, and yes A2 ಎದುರಿಗಿಲ್ಲ, therefore A1 Z ಇದೆ, B1 X ಇದೆ, B2 Y ಇದೆ. So A1, B1 and B2 they all have IR activity, but A2 it will not be having IR activity. It is correct. So A2 ಬಿಟ್ಟು ಉಳಿದಿದ್ದು ನಾರ್ಮಲ್ ಮೋಡ್ಸ್ ಏನ್ ಉಳಿದಿದ್ದು ಮೋಡ್ಸ್ ಟೋ ವಿಬ್ ಏನ್ ಬರುತ್ತೆ, that is to be worked out. For that, first what we should do is we should calculate something called as TOW 3n. So like if each and every atom it is fixed with XYZ coordinates, what will be the reducible representation that we get, that we need to work out, right? For that what we do is we take number of unshifted atoms during all these operations. So idu molecule, if you consider this molecule, totally 10 atoms are there, and if you perform the operation E, identity operation madidre, how many atoms they remain unshifted? I'm not asking about shifting, unshifting. So like E, it will not alter the position of any atom, so therefore all the 10 atoms they will be unshifted. C2 if you do, so C2 it will be along with this itself, so therefore like all the atoms they will be shifted, and unshifted it will be 0. Similarly sigma V, if you consider this as sigma V, ಸೊ ಇಲ್ಲಿಯೂ ಕೂಡ ಅಷ್ಟೇ, ಅದು ಸಿಗ್ಮಾ ವಿ ಡ್ಯಾಶ್ ಅಂತ ಆಗಬೇಕಾಗಿತ್ತು. ಸೊ CV1 ಅಂತ ಏನೋ ಮಿಸ್ಪ್ರಿಂಟ್ ಆಗಿದೆ. ಸೊ ಆಲ್ ದೀಸ್ ಮಿಸ್ಪ್ರಿಂಟ್ಸ್ ನಾವು ಅದಕ್ಕೆ ಗ್ರೇಸ್ ಮಾರ್ಕ್ಸ್ ಕೇಳಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ KSET ದಲ್ಲಿ. ಸೊ ದೇ ಡೋಂಟ್ ಇವನ್ ಕನ್ಸಿಡರ್ ದಟ್. ವಿ ಶುಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಮಿಸ್ಪ್ರಿಂಟ್ ಇದ್ರೆ ವಿ ಶುಡ್ ಬಿ ಇನ್ ಎ ಪೊಸಿಷನ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಟ್ ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಸಿಗ್ಮಾ ವಿ ಡ್ಯಾಶ್ ಆಗಬೇಕಾಗಿತ್ತು. Fine. So now sigma V dash, so that I consider the plane of the molecule, right? That is also vertical plane itself, that I consider it as sigma V dash. So if you perform that, right? So ಅದು ಒಂದು ಆಪರೇಷನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಆಲ್ ದ ಆಟಮ್ಸ್ ಆನ್ ಸಿಗ್ಮಾ ವಿ ಡ್ಯಾಶ್ ಅಲ್ಲಿ ಪೊಸಿಷನ್ಸ್ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ. ಸೊ ದೇರ್ ಫಾರ್ ಅನ್ಶಿಫ್ಟೆಡ್ ಆಟಮ್ಸ್, ಆಲ್ ಆಫ್ ದೆಮ್ ದೇ ವಿಲ್ ಬಿ ರಿಮೈನಿಂಗ್ ಅನ್ಶಿಫ್ಟೆಡ್, ಸೊ ಇಟ್ ವಿಲ್ ಬಿ 10. So now to work out this TOW 3n, this NUA, number of unshifted atoms, that is to be multiplied with contribution. So like each atom's contribution ಏನಿರ್ತದೆ ಅದನ್ನು ವರ್ಕೌಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಅಫ್ಕೋರ್ಸ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್. ಡೈರೆಕ್ಟ್ಲಿ ನಿಮಗೆ ಕೊಡೋದಿತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಫಾರ್ ಇ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಅದರದ್ದು ಸಿಂಪಲ್ ಹೇಳಬೇಕು ಅಂದ್ರೆ ಇ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಗೊತ್ತಿದ್ರೆ ಅದರದ್ದು ಪ್ರಿನ್ಸಿಪಲ್ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಸಮ್, ಕ್ಯಾರೆಕ್ಟರ್ ಆಫ್ ದಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ದಟ್ ವಿಲ್ ಬಿ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ 3. ಫಾರ್ C2 it will be -1, for sigma V it will be 1, and for sigma V dash for planes always it will be 1. And now if I multiply these two, 10 into 3 it will be 30, and 0, of course here it will be 0, again here it will be 0, and 10 into 1 it is 10. So this is TOW 3n, right? See, this TOW 3n, it should be broken down into its irreducible components. Again, we should make use of standard reduction formula. I have not shown that. So if you know how to make use of standard reduction formula, then only you can realize how I have done this. That's what I said. This is definitely a difficult end, time consuming. difficult ಅನ್ನೋದಕ್ಕಿಂತ time consuming problem. So if I do that, if I split this tau 3n into its irreducible components, it will be 10a1 plus 5a2 plus 5b1 plus 10b2 ಅಂತ ಬರ್ತದೆ. So now from this you should work out only tau wib. So 3n ದಿಂದ tau wib ಮಾಡೋ ಮೆಥಡ್ ಗೊತ್ತಿದ್ರೆ tau 3n ದಿಂದ tau translational and tau rotational ತೆಗೆದ್ರೆ what we are getting, that will be just tau vibrational. So 3n, it is nothing but this 10a1 plus 5a2 plus 5b1 plus 10b2. I have not written it, right? Then minus tau trans. So tau trans, this x ellide, that corresponds to one translational mode, that is b1. Y, one more b2. Z, it is one more a1. So therefore a1 plus b1 plus b2, or say a1 plus b1 plus b2, that will correspond to translational, tau translational. Similarly tau rotational, wherever you find rx, ry, rz, that will correspond to rotational modes. So therefore it will be again a2 b1 and b2. Here you can find rz, ry, rx. So therefore a2 b1 b2. So if from this all these things it is deducted, we are left with 9a1 plus 4a2 plus 3b1 plus 8b2. What they say is that a2, it is IR inactive, that they have said. So therefore otherwise also we can make it out, we can just leave that. We are left with 9a1. If I don't consider this, I will be left with 9a1 plus 3b1 plus 8b2, and you can find one such option, 9a1 plus 3b1 plus 8b2. It is this, right? So definitely exam dalli ಮಾಡೋದು ಕಷ್ಟ, but ಈಗ ಎಕ್ಸಾಮ್ ಮುಗಿದ ಮೇಲೆ ಯು ಕ್ಯಾನ್ ಟ್ರೈ ಡೆಫಿನೆಟ್ಲಿ ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನು ಟ್ರೈ ಮಾಡ್ಕೊಂಡ್ರೆ ವೆನ್ ಯು ಆರ್ ಅಪಿಯರಿಂಗ್ ಫಾರ್ CSIR net, definitely will be helpful, right? So this was 70th question. So next question, it was straight away. Few questions from physical chemistry, they were very very straight. So this one, Stirling approximation. So if you know when the Stirling approximation is used, it is very very simple. So Stirling approximation, it is used to work out the factorial of very large numbers. So very large numbers factorial working out, it becomes difficult by making use of this approximation. So like close value of very large value, its factorial, it can be worked out, and the equation I have given, so like n factorial, that will be equal to square root of 2 pi into n divided by n upon e is exponential number whole raised to n. So therefore mainly it is to work out the factorials of large integer numbers. So maybe those who are from mathematical background, for them it should not be difficult, easily it should be possible to get the answer for that question. So next question, this is also very very straight away. So phase rule, it is applicable. When phase rule it can be applicable, that is the question. And in fact phase rule, it's short form of what is called as equilibrium phase rule. Whenever say two components, they are in equilibrium with each other, then only this phase rule it can be applied. Actually we should call it as equilibrium phase rule. So that is, in short, we will be calling it as phase rule. So therefore when the system it is at equilibrium, that is the correct answer for 72nd question. This was also very straight away and very simple. So the next question, 73rd question, it is, which is thermodynamic state function, or what is thermodynamic state function, that they have asked. So in thermodynamics, basic knowledge of thermodynamics if you have, we will come across two kinds of functions. So state function and path function. So state function is that particular property of the system whose value, it depends only on the present state of the system. What is the present state of the system? Only based on that, if any value of the system it is decided, that will be called as state function. So it will not depend how the system has exactly come to that particular state, right? At present, what is the state? Only if the value of that particular property is dependent on that particular thing, that is the present state of the system, that will be state function, right? So just even if you know this much, you can answer this. Whose value depends on temperature only? No, this is not correct one. So maybe this is wrong, right? So here this temperature part is wrong. Whose value is independent of path, right? So this seems to be the correct, this seems to be correct. We may look at the other options also, because if it is state function, so path means the way in which the system it has come to that particular state. State function, it will not be dependent on that. So based on that, you can just think that B can be the answer. So you can just look at the other options also, used to determine heat changes, used to determine pressure, volume, work. So these are just fillers, some options they have given. But there is one more which is known as path function. So like path function means it is the property which depends on the path in which the state has been reached, that is called as path function. Example for state function: enthalpy and entropy, internal energy, density, many are there. H, it is for enthalpy, S, it is for entropy. When it comes to path function, Q, that is amount of heat added to the system or heat removed from the system, that is Q. And W, work done on the system or work done by the system, that one W. So that actually these two, they are two important path functions, right? So, but the question is about shape functions, so therefore this one whose value is independent of path, that is the correct answer. Option B was the correct answer for this, right? So this question, definitely I suspect from all directions. I have just thought over this question, and I suspect printing error in this question, because of which grace marks can be demanded. ಕೊಡ್ತಾರೋ ಇಲ್ಲೋ ಗೊತ್ತಿಲ್ಲ, but I expect that grace mark should be given for this. ಯಾಕಂದ್ರೆ ನೀವು ಕರೆಕ್ಟ್ ಟೆಕ್ನಿಕಲ್ ವೇದಲ್ಲಿ ಹೋದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ we can suspect a technical error in this question, right? See, what they have asked is based on first law of thermodynamics, which is correct ಅಂತ ಕೇಳಿದ್ದಾರೆ. So seriously speaking, none of this they are correct, right? So why? You can just see it here. Mathematical form of first law, it is delta U is equal to Q plus W, right? So IUPAC convention, it is that delta U is equal to Q plus W. This itself is to be used. Of course, in physics literature, you may find it in the other way, like Q minus W and use ಮಾಡ್ತಾರೆ. But for chemists, IUPAC recommendation, it is to be considered. System, it is the central dogma for us. Energy, it is added to the system or removed from the system, that we will be bothering. So therefore the equation, it should be delta U is equal to Q plus W. So if you keep this as the basic equation, if it is isothermal process, for isothermal process, delta U is equal to 0, right? So for isothermal process, change in internal energy, this is change in internal energy. Temperature constant ಇರ್ತದೆ ಅಂದ್ರೆ internal energy change ಆಗೋದಿಲ್ಲ. So therefore delta U, it has to be 0. So if that is the case, ಈ equation ಅಲ್ಲಿ ನೀವು delta U is equal to 0 substitute ಮಾಡಿದ್ರೆ Q plus W is equal to 0 ಅಂತ ಆಗುತ್ತೆ. So therefore either it is Q is equal to minus W or minus Q is equal to W in any way, right? So in this way you can write. For isochoric process, work done, it will be 0, because so if we are talking about work in this kind of systems, it will be pressure volume work, and isochoric process means it will be volume constant. If volume constant, no work is done on the system, or even work it is not done by the system. So therefore work done, that will be 0. So ಇಲ್ಲಿ ನೀವು W substitute ಮಾಡಿದ್ದು 0 ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ delta U is equal to Q. But what they have given is delta U is equal to minus Q ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So ಇದು ಆಗೋದಿಲ್ಲ, right? So then next adiabatic process they are speaking about. Adiabatic process, in that case, heat added to the system or heat liberated by the system, that will be 0. Therefore Q effectively it will be 0. Q is equal to 0 if you substitute in this equation. Delta U is equal to plus W anta bartade. So but here it is minus W, so therefore that cannot be the answer. For cyclic process, again delta U, that will be is equal to 0 itself. For even cyclic process, change in internal energy, that will be equal to 0 itself, right? So here also if you go with equation, what you get is that Q is equal to minus W ಅಂತಾನೆ ಬರ್ತದೆ, right? ಬಟ್ ಇಲ್ಲಿ ಎಲ್ಲಿಯಾದ್ರೂ ಒಂದ್ ಕಡೆ ಅವರು ಮೈನಸ್ ಕೊಡಬೇಕಾಗಿತ್ತು. ಸೊ ಐದರ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ ದೆನ್ ಯು ಕುಡ್ ಹ್ಯಾವ್ ಸೆಡ್ ದಟ್ ದಿಸ್ ಇಸ್ ಕರೆಕ್ಟ್ ಆನ್ಸರ್, ಆರ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ ಇದು ಕರೆಕ್ಟ್ ಅಂತ ಹೇಳಿಕ್ ಬರ್ತಿತ್ತು. ಸೊ ಅದನ್ನ ಮಿಸ್ ಮಾಡಿದ್ದಾರೆ ಅಂತ ನನ್ನ ಒಪಿನಿಯನ್, ರೈಟ್? ಸೊ ಬಟ್ ವಾಟ್ ದೇ ವಿಲ್ ಬಿ ಗಿವಿಂಗ್, ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಅಂತ ಕೊಡ್ತಾರೆ ಗೊತ್ತಿಲ್ಲ. ಸೊ ಇವ್ ಎರಡರಲ್ಲೇ ಯಾವ್ದಾದ್ರು ಒಂದು ಬರುತ್ತೆ, ಎ ಆರ್ ಡಿ ಬರುತ್ತೆ. ಬಟ್ ವಾಟ್ ಐ ಸಸ್ಪೆಕ್ಟ್ ಇಸ್ ದಟ್ ಮೈನಸ್ ಸೈನ್ ಇಟ್ ಇಸ್ ಮಿಸ್ಸಿಂಗ್, ಪ್ರಿಂಟಿಂಗ್ ಎರರ್ ಆಗಿದೆ ಅನ್ನೋದು ನನ್ನ ಒಪಿನಿಯನ್. So from all possible directions I have thought over this, and I have even referred books. So this particular thing I could get exactly ಇದೇ ತರ different process ಅಲ್ಲಿ ಇರುತ್ತೆ ಅನ್ನೋದು ನನಗೆ ಒಂದು ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ ಸಿಕ್ಕಿದೆ ಕೂಡ. But like based on this, if I go, I can say that none of these they are correct answers, right? So but what I am suspecting in the key answers, if this is not informed to them prior to key answer, either A you may get as answer or D. ಮೋಸ್ಟ್ ಪ್ರಾಬಬ್ಲಿ ಡಿ ಕೊಡ್ತಾರೇನೋ ಅಂತ ಅನಿಸ್ತದೆ. ಸೈಕ್ಲಿಕ್ ದಲ್ಲಿ ಹೀಟ್ ಆಡೆಡ್ ಅಂಡ್ ವರ್ಕ್ ಡೌನ್ ಸೇಮ್ ಇರಬೇಕು ಅನ್ನೋ ಬೇಸಿಸ್ ಮೇಲೆ ಇದನ್ನು ಕೊಡ್ತಾರೋ ಏನೋ ಗೊತ್ತಿಲ್ಲ ನನಗೆ. ಬಟ್ ಟೆಕ್ನಿಕಲಿ ಸ್ಪೀಕಿಂಗ್, ಮ್ಯಾಥಮೆಟಿಕಲಿ ವೇ Q is equal to minus W, that was expected, that was the expected correct answer. Anyhow, we shall go with the next question. Again, this is very simple, based on, say, if you know something about kinetic molecular theory of gases, from that this can be answered. An ideal gas as compared to real gas at very high pressure. It's a very important thing. They are asking about ideal gas, and you should compare it with real gas at high pressure. So if you consider real gases at high pressure, so real gases, they will be behaving really. So like ideal ಅಂತ ಹೇಳಿದ್ರೆ kinetic molecular theory of gas ಅನ್ನು absolutely follow ಮಾಡುತ್ತೆ. Real gases, they are real, so therefore they will not 100% obey those ideal gas equations and ideal gas rules. So therefore at high pressure, when molecules they come close to each other, they develop some attractive interaction, real gases. So therefore because of their attractive interaction, this molecules they are coming closer and volume it has to decrease. But the same thing it will not happen with the case of ideal gases. Ideal gases, if they behave ideally according to kinetic molecular theory of gases. So even if they are kept at high pressure, they should not develop any attractive interaction. In that case, they will have little more volume as compared to that of this. Because volume it decreases in the case of real gases, this one ideal gas, it should have little more volume. So therefore option A, that was the correct answer for this question. Right. The next question, it is according to molecular orbital theory, the shape and size of molecular orbital depends on, right? So very easy question. Even if you know the basic aspects of molecular orbital theory, you can answer this. So molecular orbitals, their shape as well as size, it depends on the combining atomic orbitals, their shape and size, how many such atomic orbitals they are combining, it will depend on that also, and finally how those atomic orbitals they are overlapping, right? Orientation of the combining atomic orbitals, that is how they are overlapping, it depends on all the three factors. Therefore option D should be the correct answer. Shape, size, number and orientation of combining atomic orbitals, all of this they decide the size and shape of the corresponding molecular orbital whichever is formed. Right. So next question, it is from again quantum chemistry. So those who have very basic idea of this quantum chemistry, easily they will be able to solve this question. It's not at all difficult. So what they say is that for a particle in a cube, so in a cube means it is like particle in 3D box of length A, number of degenerate functions having energy 27 h square upon 8 ma square that they have asked. Energy expression for a three-dimensional box, if you know, that will be given by this expression, E is equal to nx square plus ny square plus nz square into h square upon 8 ma square. So now this, if you compare with this equation, given energy, you can find that 27 that should be is equal to nx square plus ny square plus nz square, right? So now if nx square plus ny square plus nz square, if it has to be 27, what are the possible values of nx, ny and nz? That if I work out, so the simplest case is that all of them they can be 3. 9 plus 9 plus 9, 3 square plus 3 square plus 3 square, 9 plus 9 plus 9, 27. One possible solution. And the other possible solution is that one of them it should be 5 and other two it should be 1. Then only 5 square it will be 25 plus 1 plus 1. 1 square it will be 1. So therefore it will be 27. Right. So now degeneracy, if at all I am asking, so like in how many different ways we can get that value 27, that is to be checked. So one possible way it is 333. Second one 511, right? 5 I have kept it as nx. So in the second way I can make ny as 5, and in the third case I can make nz as 5. So therefore 4 possibilities are there. So if 4 possibilities, in 4 possibilities we can get this value 27. In that case degeneracy it should be 4. Therefore correct answer for this, it is option D, option 4, option D, which is 4. Fine. The next question, this is also from quantum itself. Again it is very simple one. So they have given a function as 2 raised to 1 plus ix. What is the value of the product of this function and its complex conjugate? So if you know its complex conjugate, then easily you can work out this without any difficulty. So function, they have given it as 2 raised to 1 plus ix. Complex conjugate f star fx into f star x has been asked. So therefore 2 raised to 1 plus ix, that is to be multiplied with its complex conjugate, which is 1 minus ix. For 1 plus ix, 2 raised to 1 plus ix complex conjugate, it will be 2 raised to 1 minus ix. So if I take the mathematical simplification, 2 it is so it's like a raised to m and a raised to m into a raised to n, so which will be a raised to m plus n. 1 plus ix plus 1 minus ix. Plus ix minus ix, it can be cancelled. So 2 raised to 1 plus 1, which will be 2 raised to 2, which is nothing but 4. And for this also the correct answer, it was option D itself, and which was 4 itself. 78th question. Next, 79th question. So in fact this requires a lot of calculations. This is based on molecular orbital theory, but from simple considerations, even if you don't want to solve those equations and all, from that perspective you want to solve this. So like pi electron energy, it will be minimum for benzene, it will be because of pi electron delocalization. Actually then calculate ಮಾಡಬೇಕು. Maybe if it is necessary I will just attach it in the pin in the comment. I'll pin that comment. So maybe if it is video or some solution calculations, if they are necessary, I can give that. So simple way they'll solve ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ they for benzene pi electron delocalization it will be maximum, so therefore its pi electron energy it will be minimum, right? So next will be trans, where efficient delocalization is possible, trans butadiene. The next one it will be cis butadiene. So cis iddaga compared to trans conjugation it will be less, or resonance it will be less. So the next one it is ethene, where the conjugation or delocalization is not possible, so therefore you should follow this one. So according to this, if I go with the answer straight away, D is the answer without any calculations. If you want to make this, then So simply with the knowledge of delocalization that is possible, you can say that D is the answer. So exact calculations it is little complicated. So that is to be done, right? So maybe I'll attach it in comment. So the next question. This is also simple one. It is just based on the operators and commuting properties of operators. Which of the following two operators commute with each other, right? So four they have given. So it's not even necessary that if you have this basic idea of calculating the method, so in that case easily you can mark that option A is the answer for this. Others they are not the answers. Other different operators whatever they have given, actually they will not commute with each other, right? So the first one, that should be the answer. How, if you want to do that mathematically, so if two operators they should commute, then this property it is to be satisfied, that is A into B, operator A into operator B, product of these two, that should be is equal to B into A, right? Here always AB that will not be equal to BA. Only when A is equal to A operator into B operator, that is equal to B operator into A operator, in that case only we say that they commute, otherwise they will not commute with each other. So now what I do is that I consider that this first operator A, I'll keep it as d by dx, and the second operator B, I'll take it as d square upon dx square. So now first on a function, I'll consider the operation in this particular order, that is operator A into operator B, then function. So this one it is d by dx, and B if I operate it on function f, so it will be simply d square upon dx square of f, and further if I simplify this will be d cube f upon dx cube. Similarly, if I do it for operator B into operator A on the same function f, any function f we can take it. So let's say the function it is f. So here this one I'll write it as it is, d square divided by dx square, and this one it is d by dx on operating on f, so therefore it will be df upon dx. So simplification, it will give you d cube f upon dx cube. So here itself you can make it out that if you go with say this one A into B, that is equal to B into A. So therefore systematically, if at all it is to be said, on the function A into B of f, that will be equal to B into A of f. So therefore f same ಇರೋದ್ರಿಂದ it should be A into B, which is equal to B into A. So that for the first option, this one A, that should be the correct answer for this. Right. So the next question, it is from chemical kinetics. Usually numerical problems will be asked from chemical kinetics, but even in the last exam, based on the elementary idea of this chemical kinetics knowledge, question was there, and even this time the order of a chemical reaction is 0, then it is, if the order of the chemical reaction it is 0, so they are asking which of these it is very certain. See, this exothermic and endothermic, actually it has got nothing to do with this 0 order, so they are just fillers, so therefore you can just neglect them. So between these two, the point is that if the reaction is 0 order, and if you imagine it to be elementary, if 0 order reaction, if it is elementary, for elementary reactions, molecularity and order, they will be same. For elementary reaction, whatever is the molecularity, number of molecules involved in the reaction, that itself should be its order, right? So in that case, the molecularity of the reaction, it has to be 0 if elementary reaction it is having 0 order. But if a reaction it can have molecularity 0, that is really not possible. So it is as good as reaction it is not at all happening. So therefore molecularity of a reaction it cannot be 0. So if molecularity it cannot be 0, in that case it is not possible that a elementary reaction it can be 0 order. So if it is 0 order reaction, definitely some other more steps must be involved, and because of that the mechanism it should be complex one. So therefore option D, that is the correct answer for this, right? So mostly this will be the last question of this particular video. Remaining questions I'll be making it as separate video, just to keep the length of the video as small as possible. So this is also a good question. What they have given is the enthalpies of reactants and products of a chemical reaction. They say that it is X and Y, right? See, one particular thing, they have not given whether the reaction is exothermic or endothermic. So based on that, whether X is greater or Y is greater, that is to be decided. But still, even if they have not mentioned whether this reaction it is exothermic or endothermic, doesn't matter. So then exothermic ಅನ್ಕೊಂಡ್ರು same answer ಬರುತ್ತೆ, endothermic ಅನ್ಕೊಂಡ್ರು same answer ಬರುತ್ತೆ. So now this situation, it assumes that the reaction it is considered to be exothermic. Reactant energy it is less, reactant energy it is more, product energy it is less, right? So now they say that this is energy of enthalpy of reactants, it is X, Enthalpy of reactants, it is Y, and enthalpy of products, it is Y, and Z, it is the activation energy of backward reaction, right? That's what they say. Of backward reaction, Z, they say. That has been represented here. So now energy of activation for forward reaction, which I have represented it as A, this is to be worked out. See now how you can do this based on X, Y, Z values. EA, that should be is equal to, right? So this is from here to here, it will be Z minus this portion. If I do that, that will give me EA. So Z minus this portion means it will be X minus Y. This portion I can just work it out by X minus Y, right? So therefore EA, that will be equal to Z minus X minus Y. So Z minus X, and this will simplify to plus Y. So adane rearrange ಮಾಡಿ ಬರೆದ್ರೆ what I get is Y minus X plus Z, right? And you can find one of the option as Y minus X plus Z, that is option D. That can be the answer. So of course we can verify the other possibility, thinking that the reaction, it will be endothermic. In that case, reactants, they will be having less energy, and product, it will be having more energy. And because of that itself, product ಆಗಬೇಕಾದ್ರೆ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಬೇಕಾಗಿರುತ್ತೆ, energy it will be absorbed, and it's endothermic reaction. So now you can make it more easily. Idikintanu easily you can get the answer. They are asking about energy of activation for forward reaction. For backward reaction, energy of activation, it is this. This is given to be Z. So this EA, that should be again equal to Z plus this one plus this particular portion. This particular portion, it will be again Y minus X in this case, right? So again it is Y minus X. So therefore Z plus Y minus X, which can be rearranged to Y minus X plus Z. So Y minus X plus Z, option D, that is the correct answer for this. So you assume the reaction to be exothermic, endothermic, doesn't matter. We will end up in the same answer, Y minus X plus Z. Fine. Yeah. So these are the first 18 questions of KSET-21, for which I have provided detailed solution. For remaining 18 questions also, soon I'll be providing you the solution. So because in YouTube, detailed solution on physical chemistry KSET-21, so far it is not available. So considering that in mind, I was busy, otherwise I could have done it some 2-3 days back. So but now I made time to make this. So if you have liked this, you can just subscribe to this channel if you have not subscribed yet, and to get notifications, you can just press bell icon, so that whenever I upload the next part of the video, you will be notified regarding that. And you can just share this with your friends, so that even they will be benefited. So lastly, if you are interested to join a long-term batch for KSET or net coaching, this particular batch, net J22 batch, it has recently started. Just one chapter I have completed. If still you want to join, you can just join this particular course as early as possible, right? So thank you for watching this video. Thank you again.